Movement means energy in an object's kinetic energy store. Anything that is moving has energy in its kinetic energy store. Energy is transferred to this store when an object speeds up and is transferred away from this store when an object slows down. The energy in the kinetic energy store depends on the object's mass and speed. The greater its mass and the faster it's going, the more energy there will be in its kinetic energy store. Movement means energy in an object's kinetic energy store. There's a slightly tricky formula for it, so make sure you learn it correctly. Kinetic energy equals e to the power of k equals half, and then mass and velocity speed to the power of 2. Raised objects store energy in gravitational potential energy stores. Lifting an object in a gravitational field requires work. This causes a transfer of energy to the gravitational potential energy store of the raised object. The higher the object is lifted, the more energy is transferred to the store. The amount of energy in a GPE storage depends on the object's mass, its height, and the strength of the gravitational field the object is in. Raised objects store energy in gravitational potential energy stores. You can use the equation to find the change in energy in an object's gravitational potential energy store for a change in height. Falling objects also transfer energy. When something falls, energy from its gravitational potential energy store is transferred to its kinetic energy store. For a falling object, when there's no air resistance, energy lost from the GPE store equals energy gained in the kinetic energy store. In real life, air resistance acts against all falling objects. It causes some energy to be transferred to other energy stores. For example, the thermal energy stores of the object and surroundings, if you can see the image there. Stretching can transfer energy to elastic potential energy stores. Stretching or squashing an object can transfer energy to the elastic potential energy store. So long as the limit of proportionality has not been exceeded, energy in the plastic potential energy store of a stretch spring can be found using the elastic potential energy, E, equals the spring constant and the extension.